Sometimes when using animated, we want an animation to take immediate effect. However, it's inside of an interpolation and not necessarily capable of using set value. In order to do this, we use a 0.99 cliff. What we have set up here is a box that we'll drag. When it stays on this side, it will stay a particular color. And when it goes to this side, it will turn red and flip over. First thing we need to do is set up an animated value XY that we can store our drag position in. So we'll set up an animation on state, create an animated value XY. And now we need to set up our pan responder, and we can do that in component will mount. So just assign this dot underscore pan responder, and I have a helper function called pan create. This will initialize a pan responder, and here, because we want to preserve our drag location, we'll say this dot state dot animation dot extract offset. And that way it'll move our delta on our animated value into our offset so that next time it will prepare our move to store the new delta. We don't need to do anything on release, so we can remove that. And then we will use animated.event, and we will pass in null because we don't need anything off the event. We just need stuff off of our gesture state, which is a second argument. We'll pass our dx into this.state.animation.x and our dy into this.state.animation.y. And now that we have our pan responder all ready for movement, we can go ahead and first spread our pan handlers onto our animated view. So we'll say dot 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 with the spread, this dot pan responder dot pan handlers. Now, just because we spread this on does not mean that we're ready to actually drag it. We need to do a translate x, translate y. So we'll say const animated styles is equal to transform. And the animated x value xy has a helper function. So we'll say dot 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 this dot state dot animation dot get translate transform. This will return two objects inside of an array, so we spread them into a new array because we'll apply some other transforms later, and it'll just have translate x and translate y for us. And now that we have our animated styles already, we can apply them to our animated view, and if we refresh, we can drag our box around. Now, as we drag this box around, we have half of the height here and half of the height here, so we're going to get the height of the window with our dimensions.get. And that way we can craft an input range that will be able to calculate the exact spot that we need to do our 0.99 cliff. And because our input range will be used for both the background and the scale interpolation, we can just say const input range and give an array here. And the idea behind the 0.99 cliff is that you define a value, which is our start, and then define a second value right before the other value needs to take effect. So in our case, that's going to be the height divided by 2 minus 50.01. And the 50.01 comes from this box being 50 by 50. And then we'll finish this off with height divided by 2 minus 50. That way, this sits at a 0.99 and then immediately toggles over to the next level. So if this was, say, 250, this would sit at 199.99, and then this would then say we need to kick off a new input range at 200. We'll then finish this off with height. So now that we have our input range set up, we can actually craft our interpolations. So we'll say const background color interpolate, and we'll trigger that off of this.state.animation.y.interpolate. We'll pass in our input range here. And then the other key part of the 0.99 cliff is having an output range that is either the same here if you want the animations to be the same, or just defining something that will immediately take effect on the other side. In our case, we want to have the same color when it's from 0, which is up here, to half the height, which is right here. And then as soon as it hits this cliff, it'll flip over to a pure red color. So now we can take this background color interpolate and pass it into our animated styles. So if we refresh back here, we now have a blue-purple box that we can drag. And as we drag, as soon as we hit our 0.99 cliff, we can see that it turns red immediately. There is no animation that takes effect. It instantly flips to red. Now we'll add one more interpolation. We'll do a flip interpolate. So we'll say const flip interpolate is equal to this dot state dot animation dot y dot interpolate. We'll pass in our input range, and then our output range will be 1 and 1, because this will go into scale and we want it to flip, and then -1, which will flip it over a reflection point. So we'll pass that in here to our transform. We'll put a scale here with our flip interpolate. And if we refresh, grab our box and drag, as soon as we hit this line, we'll see that our box turns red and flips over. Now, if we don't have an immediate 0.99 cliff, so for example, if we were to, rather than have a -50 here and just have a 0.199 roughly 0.99 to 250, if those were the actual numbers, then a gradual animation will happen, and that's not what we want. So if we refresh this, this will now be 50.01. So there's a 0.99 cliff, but there's not an immediate 0.01 more on the other side. And this will then actually cause an interpolation to happen. So as we get closer and closer, we can see that as soon as we get within 50, as the box touches, it'll shrink down and then grow on the other side. But once we add back our cliff, our animations will take immediate effect.